In this module, we are going to, in module 4, we are going to learn about Poisson processes. And as you guys, if you guys may remember from one of our previous sessions, I talked about the two types of random variables, discrete random variables and continuous random variables. For the discrete random variables, we said that, okay, we learned discrete uniform, we learned Bernoulli and binomial. And then for the continuous, we said that we learned continuous uniform and normal. Okay, so far in module 2 and module 3. But then in module 4, we are going to learn two more variables. One of the variables is called Poisson random variable. That's the discrete random variable. And the other random variable that we are going to learn is called exponential random variable, and that's a continuous random variable. But there is a very close relation between Poisson random variable and exponential random variable, and that's why we put these two in a separate module for we call it module 4 for this class, so that you guys can see the relation between these two variables. And but in the textbook, the Poisson random variable is still with the rest of the discrete random variables is under chapter 3, and then the exponential random variable with the rest of your continuous random variables is in chapter 4. Okay. So here in module 4, we are going to learn Poisson random variable and exponential random variable. Poisson is a discrete random variable and exponential is a continuous random variable. Just keep that in mind. The ones that we learned in these two videos so far are related to the Poisson random variable. And what we learn about Poisson random variable is that the Poisson random variable X usually has Poisson distribution with parameter alpha. And since it's a discrete random variable, it shows number of times that, for example, something has happened, an event has happened, for example, number of times that customers can arrive to Starbucks in 1 hour. How many customers come to this Starbucks in a specific time? Or number of times that calls are made to a call center in a specific hour. Things like that that have that discrete distribution. When you say number of calls made to a call center, those are discrete. Like you can say 1 call, 2 calls, 3 calls, or more. When I say number of customers that have arrived to Starbucks or to a store, then that's a discrete random variable as well. Okay. Or for example, number of requests for proposal that have been made in a year. Again, these are discrete number of things that can happen. And as you can see, we are counting this number of things in a time frame, in a year, in a month, in 1 hour, in a quarter. So we are counting number of things that have happened in a time frame, or sometimes even we can have things in instead of time, we can have measure of distance. For example, number of cracks that you have seen in a mile of the highway. Okay, we are still counting discrete things. Number of cracks. Okay, so that's 0 crack or 1 crack or 2 cracks or so forth. And then so number of cracks that we have seen in maybe in 1 mile of the highway. So yeah, so here again we are looking at number of things in a dimension of time or dimension of space. And these are all variables that have Poisson distribution. They have that nature. And if random variable X has a Poisson distribution with parameter alpha, then this random variable can get possible values from 0 all the way to infinity, because it shows us again number of things, number of events, number of cracks, number of customers. So it can go all the way from 0 to infinity. And then the probability that this random variable get any value in this range is e to the power of minus alpha alpha to the power of x over x factorial. Okay, and here one thing that you guys have to pay attention to that is going to make your life easy in solving any problem related to Poisson random variable is that this alpha, the parameter alpha here shows average number of events that can happen in a specific time frame that we are looking at. For example, if let's assume x shows a random variable that is number of customers entering a bank in an hour. Okay, number of customers entering a bank in an hour is this random variable. Again, if you look at this, first of all, this is number of customers, right? This can be 0, 1, 2, 3, or 4. It's a discrete random variable. And then we're looking at number of events that has happened in a time frame, number of customers that have entered the bank in an hour. Okay, so this is definitely definition of the Poisson random variable. And then the time frame here is an hour. What are the possible values for this random variable number of customers that can enter a bank in an hour? It can go anywhere from 0 all the way to infinity. Okay, obviously all of these are possible numbers, but their probabilities are different. Maybe the probability of having 1 million people entering a bank in an hour is very, very, very small, close to 0. But probability of having 20 people entering a bank in 1 hour is a very large number. That's a very possible number. So 0 to infinity, this range are all possible numbers, but obviously each one of them has a different priority. And in this formula here, we want to see what if, for example, X number of customers enters the bank, lowercase x. What is the probability that X number of customers enters the bank in an hour? Okay, now here, to be able to answer that question, then this parameter alpha that you have here should show average number of customers entering the bank in an hour. Okay. And this is very important to realize here, that this alpha shows average of that random variable, average of the number of customers that can enter the bank in an hour. Maybe on average, 15 customers enters the bank in an hour. Okay, fine. That's the average, but you want to know what is the probability that 20 customers enters the bank in an hour? What is the probability that no customers enters the bank in an hour? Okay, but what is important is that you understand that alpha here, this parameter, shows average of that random variable that you're looking at in that same time frame in an hour. So if you are looking, if X, your random variable, is number of customers that enter the bank in an hour, if that's the one that you're looking for and you want to know what is the probability that X is 20 or X is 30 or X is 0, then your alpha also should show average number of customers that enter the bank in the same time frame, hour. Okay, so now let's assume I define another random variable that also has Poisson distribution with parameter alpha. And let's assume this is the definition of alpha. Y equals to number of customers that enter the bank in 2 hours. Can you tell me what are the possible values for this random variable?
What are 0 to infinity.
Exactly. Still 0 to infinity. Number of customers that can enter the bank in 2 hours is still 0 infinity. 0 to infinity is this, and this variable is still has Poisson distribution because we are looking at number of things that can happen in a time frame, in a frame of space or distance or area. So this is a time frame. So number of customers that enter the bank in 2 hours is still Poisson, and these are the possible values. So can, with everything we talked about so far, can you tell me how the definition of alpha of this parameter is going to change here? What is alpha here?
Average for 2 hours.
Exactly. Then your alpha here is average number of customers entering the bank in 2 hours. That's the one that you need to calculate, and that's the one that you need to put in the formula that we wrote here. That's the one that you need to put in the formula. If you don't have it for 2 hours, you have to calculate it. You have to somehow calculate that number and then put that in the formula. Okay. If I tell you number of customers, Y is number of customers that enter the bank in 30 minutes. Okay, then your alpha becomes average number of customers that enter the bank in 30 minutes. You have to calculate that and then put that in the formula, in this formula. Okay, so that's the only thing you have to pay attention to. Now, I have a folder. If you go to module 4 folder, I have put a practice problem folder, and inside that folder there is a couple of there's a file that has some practice problems. We are going to go over those today. Okay. I hope you guys have the file open. So go to module 4, practice problems folder, and then open the file I have uploaded in that folder. Those are the practice problems that we're going to go over today. Not all of them are related to Poisson random variables. Some of them are related to the exponential random variables that you will learn in the rest of the videos. But in the next session we'll go over those. But I'll go over whatever we have learned about Poisson random variables today, till today. So the first question says, the number of telephone calls that arrive at the phone exchange is often modeled as a Poisson random variable. Assume that on average, there are 10 calls per hour. Okay. Can someone tell me, first of all, why this random variable, which is number of calls that arrive at the call center, has Poisson distribution? Why is that random variable qualified to have Poisson distribution?
It's within a time frame.
Exactly. It's number of things, first of all, number of phone calls, number of things, discrete, 0, 1, 2, 3, 4, all the way to infinity, that have happened in a time frame here, for example. In this question is a time frame. Okay, so number of calls that arrive to a call center is often modeled as a random variable, and on average there are 10 calls per hour. Okay, so on average we have 10 calls per hour. Okay, now the part A where it says determine the following probabilities. What is the probability that we have exactly 5 calls in an hour? So if I define the random variable x to be number of calls in an hour, can you tell me what are the possible values for x? Number of calls we receive in an hour. What are the possible values?
0 to infinity.
0 to infinity. And now I want to know what is the probability that we get exactly 5 calls in an hour, okay? As Dr. Parser shows in his notation, this is probability of n1, right? Number of events that happens in 1 hour. So I wanted, number of events that happens in 1 hour, number of calls that are made in 1 hour. What if the probability that is 5? Okay, for me to be able to answer this question, obviously I need to know first what is alpha. And can someone tell me what is alpha here? What do I need here?
Is it 10?
Okay. Tell me first in the sentence, what do I need to have? Alpha shows
the average
number of calls in
1 hour.
In 1 hour. That is important. If my random variable x shows number of calls in an hour, then alpha also should show average number of calls in an hour. And here in the problem is given to us. On average, we get 10 calls per hour. So the alpha here is 10. So then to answer this question is all about e to the power of minus alpha. Lambda to the power of 5 over 5 factorial. Okay, so then that becomes the answer to this question. What is the probability of receiving 5 calls in an hour? Then you need to solve this to find the answer to this, and that's the answer to your question. Okay. So the only important part in this question was to find the correct value for alpha. And as soon as you see that, okay, the x is per hour, so then alpha should be average number of calls per hour, and that's the one that is given to you, 10. So the rest is just formula, e to the power of minus alpha, alpha to the power of x over x factorial. Okay. Now let's look at part B, part B. What is the probability of having 3 or fewer calls in 1 hour? How do you write it? Probability of x, or random variable, is 3 or fewer. How do you write it? Number of calls is, we have 3 or fewer number of calls in an hour. Probability that x is
less than or equal to 3.
Less than or equal to 3. Okay, so that's equal to probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2 plus probability of x equals to 3. Okay, so you have to calculate all these probabilities and add them to each other. The only thing you have to know to be able to calculate these probabilities is that what is alpha. So my random variable still is number of calls in an hour. It says, what is the probability that we have 3 or fewer calls in an hour? Okay, so then alpha still shows average number of calls in an hour. Because my random variable is looking for number of calls in an hour. So alpha is the still average number of calls in an hour, which we know from the previous question is still is 10. So you have the alpha. The only thing you need to do is to just put alpha in the formula for the Poisson random variable, find these probabilities and add them to each other. Okay, so for example, let's calculate x equals to 0. Again, formula e to the power of minus alpha, alpha to the power of x, which is 0, over 0 factorial. And we do the same calculation for probability of x equals to 1, probability of x equals to 2, probability of x equals to 3. Add all these probabilities together. That gives me the probability of 3 or fewer number of calls in an hour. Okay.
Excuse me.
Yeah.
What about for x equals 0? Oh, you already put it. Thank you.
Sure. Okay. Now let's look at part C. What is the probability of exactly 15 calls in 2 hours? So probability, I'm going to pick a different random variable, y. Probability of y, because here we are looking at number of calls in 2 hours. That's why I picked a different notation. Probability of y equals to y equals to 15, or as Dr. Paul's notation, n of 2 is 15, right? Exactly 15 calls in 2 hours. Okay, so now for y, or these n2 random variables, still the possible values are 0, 1, all the way to infinity. These are number of calls that we can receive in 2 hours, right? So to be able to calculate this probability, I need to calculate the corresponding alpha. Can you tell me first, what is the definition of alpha? Define it for me. Here, for this random variable, what is alpha?
Average number of calls in 2 hours.
Average number of calls in 2 hours. Because my question is asking, my random variable y is, what is the probability that the number of calls in 2 hours is 15? So my random variable is number of calls in 2 hours. So alpha should be average number of calls in 2 hours as well. So now what is alpha? From the problem statement, I have average number of calls in 1 hour is 10. So in 2 hours is 2 multiplied by 10. That's 20. Okay. And then probability that this random variable is 15, or the probability that number of calls in 2 hours is 15, is e to the power of minus alpha to the power of x over x factor over 15 factorial. Okay, that is my probability. The only thing I needed was to be able to find alpha correctly. The rest is just plugging the number in the formula. Okay. And for part D, it asks, what is the probability of exactly 5 calls in 30 minutes? So here I'm looking at number of calls in 30 minutes. So I'm going to use notation Z. So notation Z is number of calls in 30 minutes. That's my random variable. And I want to know what is the probability of that number of calls in 30 minutes is exactly 5. That's what I want to know. Or probability of n, 30 minutes is half of 1 hour, right? So that is n of 0.5 is 5, if I want to use the notations in the video. So I have to find this probability. So my very first step is to find the correct alpha. What is alpha here? Can you define the alpha for me? Average number of calls in how long?
30 minutes.
30 minutes.
In 30 minutes. Okay. So given the fact that I know average number of calls in 1 hour is 10, in 30 minutes is 1 over 2 divided by 10. So new alpha is 5. So then probability of Z is 5, or probability of n of half an hour is 5, is e to the power of minus 5, 5 to the power of 5 over 5 factorial. Okay, that answers your question. Any questions so far, guys? Okay. Question 2. Number of cracks in a section of interstate highway that are significant enough to require repair is assumed to follow a Poisson distribution with a mean of 2 cracks per mile. So my random variable x shows number of cracks in a mile of highway. Okay, so this is a Poisson random variable. Why? Because Poisson random variable shows number of things, number of cracks, number of customers that enters, number of calls that are made, number of proposals that were received, like number of things in a time frame or in a frame of space or in a frame of area or in a frame of length. So here we show number of cracks in a mile of highway. That's the perfect definition for a Poisson random variable. Can you tell me what are the possible values for x? Number of cracks in a mile of highway?
0 to infinity.
0 to infinity. Okay. Now it says, what is the probability that there are no cracks that require repair in 5 miles of highway? So the probability of no cracks in 5 miles of highway. If I want to use the notation, that's probability of n of 5. Number of cracks in 5 miles of the highway. So the probability that there is no cracks, so 0. So the probability that number of cracks in 5 miles of the highway is 0. No cracks in 5 miles of the highway. I want to find this probability, okay? So first, I have to find the corresponding alpha. Can you tell me what is the definition of the whole alpha? Just give me one sentence. What is alpha? If you just want to write it in a sentence.
Average number of cracks on the highway.
How long?
1 mile.
Here I'm going to look at number of cracks. There are no cracks in 5 miles of the highway. So here I'm going to look at number of cracks in 5 miles of the highway. I want to see what is the probability that there is no cracks in 5 miles of the highway. So as if this is a new random variable. So this is a new random variable other than the random variable x that we initially defined. This random variable, both of them have Poisson distribution because both of them are number of things in a measure in a dimension of space or times. So both of them are number of things. So both of them are Poisson distribution. Both of them vary between 0 to infinity. And now I want to calculate that what is the probability that this random variable is 0, number of cracks in 5 miles of the highway. So then my average, my alpha should show number of cracks, average number of cracks in 5 miles of the highway. Okay, give me 1 second, let me, okay, minimum cracks. So now my alpha for this random variable n5 should show average number of cracks in 5 miles. of highway. Just because here I'm looking at the probability of no cracks in 5 miles of the highway, as if number of cracks in 5 miles of the highway, the ones here, number of cracks in 5 miles of the highway is a random variable, has Poisson distribution, and I want to know what is the probability that this random variable is 0. And alpha corresponding to this should be average number of cracks in the same mile of the highway that the random variable is asking about. Alpha should show average number of cracks in 5 miles of the highway. And from the question, I know that it says the random variable has a Poisson distribution with a mean of 2 cracks per mile. So if I have 2 cracks per mile in a 5 miles of the highway, I have 2 multiplied by 5, 10 cracks in 5 miles of the highway. So average in 5 miles of the highway, I have 10 cracks. So that's the alpha I have to use to answer this question. So then probability of n5 equals to 0 is e to the power of minus 10, 10 to the power of 0, 0 factorial. Okay, so pay attention that, guys. Yes, x is the random variable that shows number of cracks in 1 mile of the highway. X has Poisson distribution, perfect. And now I'm asking about a number of cracks in 5 miles of the highway. Okay, this random variable, this is a new random variable. This random variable also has a Poisson distribution, and it shows number of cracks in 5 miles of the highway. Okay, perfect. So now to be able to answer the things related to this question, to this random variable, to be able to answer the questions related to this random variable similar to this one. What is the probability that number of cracks in 5 miles of the highway is 0? I have to find the new alpha, which I did here. And those shows average number of cracks in the same mileage that the question is asking for in 5 miles of the highway. And once I find the new alpha, then all I need is to replace it in the formula and answer the question. So
the original average of cracks in the mile is 2?
Yes, that's the one that is given in the problem.
Okay.
It says with a mean of 2 cracks per mile. Okay, now I want you to answer this question. Let's say this is part C of the same question. It's not there, I'm just making it up. So what is the probability of 1 crack in half a mile of highway? Can you answer this question for me? Can you tell me how to calculate?
The alpha is 1.
Okay, so you're right, but let's go over step by step so everyone can understand. First of all, I'm looking here at the new random variable. This random variable is number of cracks in half a mile of the highway. Okay, so this random variable, this shows number of cracks in half a mile of highway. Okay, that's my new random variable. This random variable still has Poisson distribution, and still possible values go all the way from 0 to infinity. However, this random variable, to be able to answer questions related to this random variable, for example, probability that number of cracks in half a mile of the highway is 1. If I want to answer questions like this, I have to find corresponding alpha, and corresponding alpha shows average number of cracks in the same length of the highway that this question is asking. Average number of cracks in half a mile. And how should I find that? The question tells me average number of cracks in 1 mile is 2. So average number of cracks in half a mile then is 1. Okay. So then with the new alpha, that is 1, if I want to find the answer to this question, that is going to be e to the power of minus 1, 1 to the power of 1 over 1 factorial. It just happens that and we need to find the value of the variables to be 1, and the alpha is 1 as well, so that's what we have. Okay. Actually, part B is similar to this. So part B, it says, what is the probability that at least one crack requires repair in half a mile of the highway? How do you write that? Probability of at least one crack in half a mile of the highway. And we just said here the random variable that shows number of cracks in half a mile of the highway. I showed it by n of 0.5. At least one crack. Probability that n of 0.5 is less than or equal to 1, which is probability that n of 5.5 is 0 plus probability that n of 5 is 1. Okay. So I need to calculate these two. We already calculated the n of 5 equals to 1, calculate the n of 0.5 equals to 0 as well, and then add them with each other, add them to each other, and then you have the answer. Okay. Let's see. Okay. Then the next question is related to the exponential random variable, which is related to the rest of the videos that you're going to watch. So we'll do that in the next session. But let me give you another example. Okay, let's assume we say we define this random variable. Number of junk emails you get in your mailbox in an hour. Okay, so this is obviously a random variable, number of junk emails that you get in your mailbox in an hour. It varies from hour to hour. So that's a random variable for sure. Can you tell me why this random variable is qualified to be a Poisson random variable?
It's within an hour.
Okay, that's one. What is the other thing? Which is a bit more important.
It will be an average rate, like the number of junk emails, so it would be 0 to like infinity.
Yeah, it shows number of things that happen, number of junk emails that you get, number of things that happen in a time frame or in a space dimension or in a length dimension, like the highway examples. Okay, so it's not just because it's in time, it's Poisson random variable. It shows number of events that can happen, number of emails that you can get, number of calls that can be received, number of customers that can be received, number of cracks in the highway that you can see, number of things that can happen, and then in a time frame or in a specific length or in a specific area, like things like that, like it has a measure of time or space or distance, something like that. So these are all definitions of Poisson, are great for the a great part, are part of the definition of the Poisson random variable. Okay, so and then like any other random variable, if I let's assume I call this X, number of junk emails that you get in your mailbox in an hour. So then X, like any other Poisson random variable, can be 0 email, 1 email, all the way to infinity. And then okay, so then if I ask you what is and let's assume I give you an average. So let's say on average we get 3 junk emails in an hour. Okay, I give you that. Now I ask you, what is the probability that the number of junk emails that you get in 3 hours is 10? What is this probability? Okay, so then this looks as if you have a new random variable right now. This new random variable looks at number of junk emails in 3 hours. No worries. Still, I'm looking at number of things in a time frame. Still, it's definition of a Poisson random variable. However, here I have to pay attention that the time frame that I have here is 3 hours. So the alpha that I need to answer anything related to this question gives me average number of calls. Average number of junk emails in 3 hours. I have to find this and then answer any question related to this random variable. So if I know average number of junk emails in 1 hour is 3, then average number of junk emails in 3 hours is 3 by 3, which is 9. Okay, with this alpha 9, then I can answer this question as the probability of n3 equals to 10 is e to the power of minus 9 to the power of 10 over 10 factorial. Okay. If I ask you, what is the probability that number of junk emails that you get in 15 minutes, which is 25%, which is 0.25 of an hour, is 1, let's say, or 0. Then, okay, now my random variable is number of junk emails in 15 minutes. That's fine. That is still fits the definition of Poisson random variable. First, I'm looking at number of things that can happen in a time frame. This time frame happened to be 15 minutes. No worries. I just have to make sure the alpha that I'm going to use shows average number of emails, number of junk emails in 15 minutes. So what is alpha here? If I know the number of junk emails that I get in 1 hour is 3, number of junk emails that I get in an hour is 3, the number of junk emails that I get in 15 minutes, which is 1/4 of an hour, is 3/4. So with this new alpha, then all I need to do is to just calculate this probability. E to the power of minus alpha to the power of 0 factorial. Okay, so there's nothing tricky about this random variable. You know the formula. The only thing you have to pay attention to is that first understand the definition of random variable. You are looking at number of things in what unit of time, what unit of length, what unit of space, or what unit of area, and things like that. Find that, and then this alpha that you put in the formula should show average of events in the same time frame or length or space or anything. Just find that and plug the numbers and you are good to go.